All right, so let's see this first slide. All right, so this is basically reducing. Okay, 15/24 times 18/24. Well, that would be divide the first one by 3. That'll be 5/8 times divide the next one by 2, and you get 9/20. And then you multiply numerators and your denominators, and you should get 45 over 160. But you could reduce again by 5 and get 9 over 32. Okay, I think that's all that we were doing on these things is just practicing with fractions. So, I mean, if you need more help with that, I can do that. But I'm pretty sure that you would know how to do this part. Okay. Some people like to reduce in the beginning. So if you have numerators and denominators that can reduce, you can do that first, like 5/8 and 9/20. Well, 5 can go into 20 one time, and into sorry, 5 can go into 5 one time and into 20 four times. And so now it's really just 1/8 times 9/4, which gives you 9/32 without this middle step. So if you want to do it like that, I encourage that. To add, you need common denominators. To subtract, you need common denominators. To multiply, you just need to multiply the numerators and denominators. To divide, you need to take the reciprocal of the second one and then multiply. So it'd be 15/24 times 8/9. And you would reduce if you can. All right. Let's clear that and see. Similarly, with rational expressions, reducing those, we want to break down the numerators and denominators into their factors and see if any of them can cancel out and reduce. For example, like this a, x cubed minus 8 over x cubed minus 2x squared. So we want to reduce these rational expressions by breaking them down and seeing if there's any numerator and denominator pieces that are the same. Now, I'm not actually sure what you've had in the past couple of years after we've done algebra. So let's see. The formula for a cube, this top numerator, is a perfect cube. X cubed and 8. 8 is a cube of 2. So that is a perfect cube. So there is a formula that helps us break that down. It's written as a minus b times a squared. This is going to take a minute. Plus ab plus b squared. Okay, that is the formula for perfect cubes and breaking them down into pieces. So if I just remember, a is x and b is 2. We're taking the perfect cubes of those. So I would write it as, let's see if I can erase that part. I would write that as, for part A, x minus 2 times x squared plus 2x, not a, 2x plus 2 squared, which is 4. Over, we can look at the denominator, and it has a common a factor of x squared. And we can pull that out, and we're left with x minus 2. Okay. And now you'll notice that the numerator and denominator both has x minus 2 in it, so we can cancel those. That x minus 2 divided by x minus 2 is 1. And so I'm just left with x squared plus 2x plus 4 over x squared. Is how I haven't done this stuff myself in a long time, so I'm hoping that this is close enough to being right, that this is what they want. Can you break this x squared plus 2x plus 4 any further? I don't actually think so, because of the middle part. If this was a 4 in the middle, it would break down. But otherwise, you'd have to use the quadratic formula on that, and that's not going to make it any easier to look at. So I think we would leave it like this. Okay, so let's look at the second one. 8 minus 2x, well, I can pull out a 2 on that one and have 4 minus x. Okay, on the denominator, we have x squared minus x minus 12. Let's see, that would break down into x minus 4 times x plus 3. Okay, because, x times x is x squared. Negative 4 times 3 is negative 12. And then you have, when you do the FOIL method, first outside, inside, last, you'd say negative 4x, and then you'd have 3x, and it'd make a negative x when you combine those. So that's just that. Now, it doesn't look like we have something similar until you think about this right here, this top part. 4 minus x is so close to being x minus 4 that we can actually turn it that way if I just swapped the signs. If I need that x to be positive and that 4 to be negative, we can actually swap signs by pulling out a negative sign, a negative 1 basically, out of this, and that means this would become x minus 4. Okay, if I pull out a negative 1, 4 divided by negative 1 is negative 4. Negative x divided by negative 1 is positive x, and so it swaps the sign by pulling out a negative. And now I have a top and bottom that is the same, and I can cancel those out. So x minus 4 cancels out, and I'm just left with negative 2 over x plus 3 for part B. Negative 2 over x plus 3 would be the lowest terms for that one. Okay? Hopefully this is all making sense. So let's go to the next slide. Multiplying and dividing rational expressions. I mean, it's basically the same with what we just did. You probably want to break all this stuff down, get rid of any pieces that you can before you start multiplying and dividing. So let's look at A. X squared minus 2x plus 1. Well, that's going to be x minus 1 times x minus 1. On the denominator, we pull out an x, and you'll have x plus 1 there. Over here on this 4x squared plus 4, well, that's going to be pull out a 4, and you got x squared plus 1. And on the denominator, it looks like it becomes x minus 2, I'm sorry, x plus 2. Oh, this should be a plus sign. X plus 2. It's very hard to do this on a mouse, without a mouse on a laptop. X plus 2 times x minus 1 would be the factors for that one on the denominator over here. All right, now you can see in the numerator I have x minus 1. I can cancel that one out with this. Oh, I didn't notice this over here. That's an x cubed. So that's actually an x squared plus 1 right there. If you pull out an x, and that canceled out with this x squared plus 1. I was wondering what was happening because I didn't notice that in the very beginning. Okay, so I'm left with 1x minus 1 and a 4 on the numerator. So 4 times x minus 1. And on the denominator, I'm left with an x and x plus 2. And that would be the fully factored form for part A. Okay, hopefully we remember how to break down and factor the individual pieces. And then once you have those individual pieces factored on the numerator and denominator, you reduce by canceling things that are the same on numerator and denominator. And what you're left with is your simplified result. Okay. It would be the same for this one over here on B, except this is going to be like a little bit longer because I have to say x plus 3 divided by x squared minus 4. And then I have to, because it's, dividing fractions, you've got to flip it over and multiply. It'll be times x cubed minus 8 on the numerator over x squared minus x minus 12 on the denominator. Okay, so x plus 3 over x squared minus 4 times x cubed minus 8 over x squared minus x minus 12. And you'd break down everything. You would find common factors that can cancel out on the numerator and denominator. Okay, let me do it. It just takes a minute. X plus 3 is already factored. This x cubed minus 8, I think we factored that on a previous problem. We can't see it because of all the writing right here, but on this one, so you would just bring that stuff over here, and this x squared. Let's see, where am I? I don't want to get too far. All right, there. X squared minus x minus 12. That would factor into x. I think we did that one on the previous one too. So you might just need to bring all your previous factors on the other problems that we just did to help you on this one. Okay, it's going to get really messy, and I kind of don't want to do it, but I can help you more if you ever need it. Hopefully you understand what I'm saying. All right, adding and subtracting rational expressions. Well, we need common denominators to add and subtract fractions. So this one, you keep the same denominator. So your denominator is going to stay 2x plus 5, and you have to add the numerators. Okay, 2x squared minus 4 plus x plus 3. Well, that'll be 2x squared, let's see, plus x. The only really thing you need to watch out is for the minus signs when it makes both of those on the numerator with a minus sign, which is negative, but that's another problem. 2x squared plus x plus, minus 4 and plus 3, that's going to be minus 1. Okay, so it would look like that. Okay, they tell you that it cannot equal negative 5 halves just because 2 times negative 5 halves would be negative 5, and negative 5 plus 5 would be 0, and you never want to divide by 0. So they do put this right here in order to prevent the denominator from going to 0. All right, can we factor 2x squared plus x minus 1? Maybe. It would come out to be, where's my marker? It would come out to be 2x minus 1 times 2x plus 1. I'm sorry, not 2x plus 1, just regular x plus 1. 2x times x is 2x squared. 2x times 1 is 2x minus 1 times x is negative x, which brings that 2x to a positive 1x. And negative 1 times 1 is negative 1. Okay, so that breaks that one down. There's nothing to combine it with on the denominator, because 2x plus 5, you really can't. There's nothing to cancel out the numerator. So I'd probably just leave it as 2x minus 1 times x plus 1 over 2x plus 5. Okay, nothing will factor out. And similarly for the second one, part B, you would keep the denominators the same, just like when you're adding fractions and subtracting fractions. X minus 3x plus 2, I would say x minus 3x is negative 2x. Okay. And then minus 2. So minus 2x minus 2 over x minus 3. You can pull out a negative 2, and so it would be negative 2 times x plus 1 if you need it factored all the way. And as I said, I'm not sure how the teacher wants your stuff to be done, but negative 2 times x plus 1 will be negative 2x minus 2 over x minus 3. Again, there's nothing to cancel out other than just having it look like this. So let's go to the next one. Just saying, doing the same thing. So this would be 2x plus 5. Oh, here's the problem with these is that they do not have a common denominator. And so you're going to need to make them, just like regular fractions, make them have a common denominator. So I'd multiply this first one by 3 minus x, and I'd probably keep everything in its own little parentheses. I wouldn't actually distribute anything just in case we can reduce later. And this one I would multiply by x minus 3, top and bottom. Okay, 5 times x minus 3, and the denominator times x minus 3. Okay, 2x times 3 minus x over denominator 3 minus x. I know this is horrible. I'm trying my best. Okay, so we can combine these. 3 minus x times 2x plus 5. Now the numerators, you do need to do the distributive property and then add those two together. The denominator you keep as 3 minus x times x minus 3. And so let's see, 3 minus x times 2x is going to be 6x minus 2x squared plus 5x, when I say 5 times x minus 3, minus 15. Okay, let's see, anything, so that'll be negative 2x squared plus 11x minus 15. If you can, you factor that and see if there is a x minus 3 or 3 minus x in there. Oop, I forgot my squared right here. All right. And so the numerator can factor into negative 2x plus 5. It's hard to type. Times x minus 3 over this x minus 3 times 3 minus x. And you can see that the x minus 3's will cancel. And so your final answer will just be negative 2x plus 5 over 3 minus x. Okay, a lot of work. I'm going to let you do the rest because, as I said, that is a lot of work. But if you can factor everything, it ends up being able to cancel that stuff. So let's see real quick. Finding the least common multiple. using the least common multiple. Okay, I'll be back on this stuff in a minute. All right, for least common multiple, you just need to see what do they have in common. This one has x minus 1 squared, and x plus 1. This one has 4, x minus 1, and x plus 1 cubed. Well, what do they have in common? They both have an x minus 1 at least, and both of them have an x plus 1. Okay, so that would be the least common multiple between both of these. Okay, you still got other stuff left over once you take those away, but at least this is what they have in common. So using that to add rational expressions, let's see. So you'd find the least common multiple in order to find and then use that to have a common denominator. I think it's pretty much what we did up here. We may not have said that though. And similarly for subtracting, you do that. Let's see, where can we find an example? Okay. So for this one, let's see. On the denominator, we would have x plus 1 times x plus 2. It's mainly because you don't want to multiply numerators and denominators by these huge long ones. You want to break it down into only the pieces you need. Plus, up here we have 2x minus 3 over x squared minus 1 is a perfect square, so we need to break that into x plus 1 times x minus 1. All right, so when I'm finding a common denominator, I don't want to multiply this first one by both of these if I don't have to. And it already has the x plus 1 on the denominator, so I don't need to multiply x plus 1 times both of them. I just actually need to multiply top and bottom on this left side by x minus 1. Similarly, when I multiply this one to get a common denominator, I just need to do it by x plus 2 since it already has the x plus 1 in common. Okay, so that would be one of the reasons you want to use the least common multiple, so that you don't have to multiply this whole numerator by both of these, or this numerator by both of these, when you can break it down and only need like part of them in order to get it a common denominator, because it's already got one piece of it. We just need these other two pieces in order to do it. Okay, hopefully that was clear. Probably not the way I talked though. All right, so let's see. Keep doing that. Complex rational expressions. When summed the differences of rational pairs of numerator and the quotient is called a complex one. All right, well, okay. So it's complex when you have fractions in the numerators and denominators. That's all right. That's a lot harder to look at than the stuff over here. So let's see. 1/2 plus 3x over x plus 3 over 4. Sorry, I'm flipping back and forth just trying to see what they want me to do. So that's going to be 1/2 plus 3x that's an x, not an 8, times, flip it over, 4 over x plus 3. All right, before I can multiply though, this numerator is one piece, so I need to separate it into a parentheses. So I'm going to need to find common denominators and combine these two before I multiply. So it looks like x over 2x plus 6 over 2x, which would be basically x plus 6 over 2x would be the that parentheses. Okay, times 4 plus x plus 3. Now we can just multiply, if you needed to, the numerators and denominators, or maybe keep them separate as, well, I guess we can reduce the 2 and the 4, so that'll be 1, that'll be 2. So it'd be x plus 6 times 2 over x plus 3. So I'm going to write it over here, so that'd be 2x plus 12 over x plus 3. Or keep it separate. I'm not sure which one your teacher would like. But that's at least the first set of slides. Hopefully that can help point you in the right direction for that set. And I'll work on getting the next set talked about in just a second, or after a while, or whenever I get some time in between my classes.